All right, this video is going to wrap up the notes part. So we're going to go over pages 34 through 36. We're going to talk about mass versus weight. Okay, so mass is the amount of substance that makes up something. Okay, so you have a mass. It's a scalar quantity, means it has no direction. Okay, it stays constant anywhere you go. Okay, so if you're in space, you have mass. If you're on Earth, you have the same mass. Now, weight is the force of gravity on an object. Okay, so if you were to take your weight, okay, it would be different here versus like on the moon. Okay, you have less gravity, so therefore your weight is going to be lower. Okay, but your mass didn't change. Okay, so mass stays the same. So we talked about force equals our mass times gravity in that case, so mass times acceleration, where A equals gravity. Okay, so that is what weight is. It's basically your mass times the factor of gravity. Okay, so what is the weight of a 25 kilogram object? Okay, on Earth and on the moon. Okay, and I gave you the gravity of the moon right there, so we're going to do our mass. Okay, so part A, we're going to figure out what is our weight on the Earth. Okay, so force equals mass times gravity, so we're going to take that 25 kilogram mass, multiply it by gravity, 9.8, and you have a weight of 245 newtons. Now what we're going to do is we're going to take that same mass, okay, but now we're on the moon, so force equals my mass, which is 25, but now my gravity is 1.6. Okay, so what I'm going to do is I'm going to multiply those, and you should get 40.25 newtons. Okay, so that is the difference between mass and weight. Now what we're going to do is we're going to talk about Newton's third law. It states that for every force, there is an equal and opposite force. One force is called the action force, and the other is called the reaction force. Okay, so that means if you push an object, the object's going to push back with the exact same amount of force. Okay, so force one, so this little diagram down here basically means that that little 1 to 2 means that is the force of object 1 on object 2 is equal to the negative. So remember, negative right here just means it's the opposite. Okay, so that means that's going to be equal to the force that object 2 puts on object 1. Okay, so if you were to like push against a wall, okay, so that is you as exerting a force on the wall. That wall is going to exert the exact same force back on you. So forces will always come in pairs. So although the forces are equal and opposite, they can cause acceleration because the forces act on two different objects. Okay, so we can have acceleration. Okay, so what we're going to do is we're talking about a foot kicking a wall. The action force would be the foot on the wall. Okay, and then the reaction force is going to be the wall back on the foot. Okay, so now ultimately you know that you're not going to win that battle. Okay, so even though you hit the wall with a certain force, that wall is going to push back with the exact same amount of force. Now the wall can handle that kind of force, but your foot cannot. Okay, so that means once that wall exerts that force back on your foot, there's a couple of things that could happen. Is one, it's going to make your foot bounce back off the wall. It's going to make your foot accelerate backwards because your foot can't handle that kind of force. So your foot has nowhere to go but backwards. And then two, it could lead, that's why you usually get things like fractures and stuff, is because you exerted a force on an object and that object exerted a force back. But things like joints, bones, and stuff like that couldn't handle that reaction force. Okay, so our next example would be catching a football. Okay, so catching a football, the action would be hands on the ball. Okay, reaction force would be the force of the football back on the hands. Now, honestly, it doesn't really matter which one's action or reaction. It's the same kind of thing. Okay, but as long as you know that they're both the exact same force. Okay, again, doesn't really matter which one you label as action or reaction. They're both the same force that are being exerted on each other. Now, if a bug splats on the windshield, okay, of your car, which experiences the greater force, the bug or the car? We just talked about that. Is every force comes in pairs. There's an equal and opposite reaction. Okay, so both experience the same force. So both the bug and the windshield is going to experience that force. Okay, now, I'm sure you can guess the bug cannot really handle that. So it says the bug has a mass of 1 gram, so 0.001 kilograms, and the car has a mass of 2,000 kilograms. If both the car and the bug experience a force of 0.5 newtons, what's the acceleration of both? So let's do the bug. Okay, bug is going to be force equals mass times acceleration. Okay, so our force is 0.5. Our mass is very small, 0.001 a. So divide both sides, and that bug's going to have an acceleration of 500 meters per second squared. Okay, so that means that bug is going to be going one direction, and then 500 meters per second, it's going to be accelerating at 500 meters per second squared the other direction. Now the car, we're going to figure out what that acceleration is. So 0.5 equals 2,000 times a. Divide both sides by 2,000, and you get 0.00025 meters per second squared. Okay, so what this basically means is the car was built for that force. Okay, so the car what's kind of crazy is that car will actually lose some of its velocity because of the bug. Okay, but it's very minimal. Okay, so that means it's going to decelerate at 0.00025 meters per second squared. So you're not going to notice it at all. You're not going to see your speedometer jump down. Okay, otherwise that's a huge bug. Okay, and then the bug is going to accelerate backwards at 500 meters per second squared, which is why it goes splat. Okay, so that bug's body cannot handle that amount of acceleration, so that's why things start to break down. Okay, so both will experience the exact same force, and both will actually they'll change their velocities at some point, okay, by some factor, but the car is going to change its velocity by very, 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 very little. That's not really noticeable. Meanwhile, the bug is going to completely change its direction very quickly. Okay, so why are some forces felt more by one object than another? Well, we just talked about that. Is mass. Mass is a factor when you think about that, is if your mass can handle that kind of force versus if it can't. The bug couldn't. Okay, so that bug's going to feel a heck of a lot more force than the car would. It's the exact same force, okay, but the bug cannot handle that amount of force. And that'll end the notes there.